আমাদের এই কাজে সবচেয়ে বেশি যারা সহযোগিতা করছেন তারা হলো ধামরাই কিছু ব্রিক ফিল্ডের মালিক এবং তাদের বন্ধুরা, তারা আমাদের এখানে আসছেন। আমি সবাইকে তাদেরকে একটু সবার কাছে পরিচিত করতে চাই। তারা যদি দয়া করে একজন একজন করে সবাই নামটা একটু বলেন এবং ডেজিগনেশনটা বলেন। কিছু বলেন, নামটা বলেন, দাঁড়ায় বলেন সবাই, যারা আমাদেরকে সবচেয়ে বেশি হেল্প করছে এই কাজে। নুরু ভাই হলো তাদের মধ্যে অন্যতম। পুরো সময় আমাদের এখানে ছিল, আমাদের খাওয়া আসছেন, উনি স্যাম্পলিং করতে দিচ্ছেন, সবকিছুর ব্যবস্থা করছেন। খুবই ভালো এবং হেল্পফুল মানুষ। আপনার নামটা একটু বলেন। নূর মোহাম্মদ ইউনিসিপির ধামরাই। আর ফারুক ভাই বলেন। আমি সাইদুল ইসলাম ফারুক, বায়োসেল লিমিটেড সিইও। নজরুল ভাই হলো ওইখানকার সভাপতি, আমরা গ্রিনফিল্ড অ্যাসোসিয়েশনের সভাপতি। আর পাশে মাহবুব ভাই উনি সেক্রেটারি। মাহবুব আরো কয়েকজন বলেন। আকাশ সরকার, আমরা বেক্স ম্যানেজার। আমার টায়ার আরেকজন দুইজন আছে। মোহাম্মদ সাইদুল ইসলাম নাকি মোহাম্মদ খলিল রহমান তিন নাম্বার। থ্যাংক ইউ। I don't know. That's all right. Oh, that was good. I think particular and good enough. Just keep it and okay.
অথবা ছোট পিসটা দাও। হ্যাঁ, that one is better.
You can hear me. You are very young. Hear me? That's not here. Just go to briefly. We already went through this. Mostly spoke about that carbon and how it impacts us. Mostly the visible component of smoke or what we call food. It is also a short-lived climate ozone which stays in the air for a few weeks, and that's why it's a big concern right now. So we are doing a few things to take care of it. The US EPA has a very specialized plant carbon program where we use a completely electric vehicle. One check showed this in his presentation too. But this vehicle is completely electric, and we actually have a number of instruments set up within it. We go to different cities, different places to take measurements, mainly near road, near highway stuff. Apart from that carbon, we also do CO, CO2, NO2, and PM. And we've done several, like tens of studies which is related to so far in many different cities, areas, and ports as well. Alright, just a few things about the Kilns in the greater Dhaka region. Most of you know these things already, but Bangladesh represents many bricks, 2.5 bricks per year, and there are more than 1,000 victims in one of these bricks located close to our site. So, a big part of the economy also greater Dhaka region. Alright, I'm going to switch to details of the victim background.
And I'll try and use the mic here so everybody can hear me. So the brick kilns, obviously the primary fuel source for the bricks being produced here is coal. Coal really is a fairly dirty fuel. If the temperatures aren't exactly right, or if you've got in leakage or cold spots potentially in your coal combustion process, you're going to see black carbon being produced as a soot particle. Along with that soot particle as it comes out are other pollutants, like what Chet mentioned. Mercury is one of them. SO2, NOx is another one. The oxides of nitrogen, all of which can contribute contribute to acid gas. Acid gas is being generated from these brick kilns. But now the kilns may also use wood or other combustible fuels to help with the preheating of the kiln. You can't just take coal and take a match to it and set it on fire. You've got to have heat to get the combustion started. And really what happens is with the combustion is you heat the volatiles in the coal start to come off. And coal is about 99% carbon. When you start heating the outside of the coal, the carbons start popping off. They combine with the oxygen to form heat and carbon dioxide. But again, incomplete combustion, you're going to form soot particles, you're going to form carbon monoxide, and along with it, you're going to carry some other pollutants out with it. Coal, despite being 99% carbon, beyond mercury, contains other chemicals, lead, cadmium, chromium, boron, and these end up potentially depositing close by, but they also contribute to heavy metals contamination in the area. Again, like Wojciech said, mercury is of particular concern. There are two forms of mercury that can be formed coming out of the co-combustion process, either an elemental mercury or an oxidized mercury. The elemental mercury becomes a global issue because it can come off and stay airborne until it deposits somewhere, whereas the oxidized mercury is a water-soluble form of mercury. So as it hits clouds or rainwater, it deposits out, falls into the sediment, fish eat it, and the people eat the fish, and you'll end up seeing increased levels of mercury coming out of the fish. Obviously, this is about black carbon, so these brick kilns have no particular control, and as I'm hoping to be able to show during these slides, really the primary control for the black carbon is occurring through better combustion efficiency out in the kiln. Being able to maintain temperatures and possibly maintain, try and control overloading of the kiln with coal to reduce these hot spots and control the black carbon. So we've been here almost 2 weeks, and we were able to visit two kilns. The one is the traditional kiln. It's an older style. The stack is in the center of the kiln, and it is naturally drafted. So just the heat of the combustion process will carry the gases up the stack along with the black carbon, and doesn't require a fan. It's just a naturally drafting process like a fireplace or a wood stove. And we visited a more advanced design, or what they call the zigzag style. And this is where the kiln is on outside of the main facility, and they use a draft fan to help remove the emissions. And because it is a newer style, and because of just the design process of the kiln, it naturally lends itself to lower emissions. These potentially can contain a water layer inside that the vapors or the gases are pulled through, which can help deposit acid gases and control some of the black carbon emissions. And the zigzag really refers to the multiple air paths that the sample travels through. And so it allows possibly a lot of the emissions to be controlled just through the geometry of the facility. So I'd like to share with you some slides that we took at the brick kilns and just walk you through the process and show you some of the things that we saw during our trip here. So my first slides here are going to be just showing some of the stack emissions, and just to give you an idea of what we saw and what we observed, and try and correlate that with the emissions data that I'm going to present here in a few minutes. These other slides, a majority of this is water, but even with a white form stack like this, we still have a number of emissions coming out. So it's black carbon. And fly ash particles. So fly ash particles are primarily composed of silica, silicon dioxide, and iron particles are the primary pieces of this plume here. Again, as we said, there are other heavy metals that are present, such as mercury, cadmium, lead, chromium, and a number of other things. Potentially calcium, there's oxides of nitrogen, and sulfur dioxide. It might be worth pointing out that in coal, because there's all the sulfur in the coal, the mercury is actually combined with the sulfur to form a mercury sulfide compound. And mercury sulfide decomposes at around 700 degrees C. So if you've got mercury sulfide in there and you've got the temperatures in your process, you're going to be decomposing that mercury sulfide into some mercury compounds that will be coming out. So here's this may be the same stack, I believe it's the same stack, under some more rich conditions. And here you can see the black carbon starting to form. You can actually see the very dark emissions coming out. You can see where it's no longer looks like steam coming out. You can actually see where the steam is dissipated, and you can actually see just black carbon plume continuing downstream. Again, here is an even darker example of the stack with the black carbon coming out. This is what we found to be indicative of very incomplete combustion. And really, it's a waste of coal. If we could learn possibly to scope these units more efficiently, the operator could see the economic benefit of not buying as much coal in the future, and that we would reduce both black carbon emissions and reduce the amount of coal consumption necessary to burn these to fire the bricks. Again, even darker. This is potentially directly after the unit was scoped. And so here again, back to this is I'm not sure if this is a zigzag design or not.
That's okay.
So this again, you can see the white plume coming out the top. But again, it may look like there's not a lot of black carbon there, but as we'll show you the data here in a minute, there's actually quite a bit of black carbon still being emitted from these stacks. Again, coal. This is coal being used. This is the coal being used in our traditional kilns that we sampled at. This is the traditional kiln. Again, this is the stack in the center with the bricks being fired around the outside of the kiln. This is the top of the traditional kiln, and these are coal buckets that are brought up to replenish the coal that's being dumped in. And I don't know if I can show you in here. These are the ports where the coal is being emptied. So, they'll begin firing at this end, and after around 24 hours after this section has been fired, they will remove these ports and move them further along the kiln, dig up a small area where they can apply these ports, these coal dumping ports, and then the guys will cover up, seal the ports up with a dirt surface to try and control in leakage, and coal will be dumped into these ports, around every 10 to 15 minutes over a 24-hour period. This is a 24/7 operation, so there's guys morning, noon, and night that work in maintaining the temperatures inside these kilns to make sure that the fire does not go out and that there's nice uniform firing of the bricks throughout the process. So here again you can see the coal ports and the unfired bricks in the yard. So these kilns appear to hire, each kiln appear to hire around 50 people at a time, and many of them were making bricks during the day so they could be dried during the day in the sun, and then adjustments were made to the bricks to make sure all the bricks were uniformly dried before they're stacked into the kiln. Here you can see this is these are fired bricks down here at the bottom, and they would be firing here actually on the opposite side and loading in bricks, new bricks around. So as fired bricks are being removed, a team is working to replenish the bricks on the other side and continue the process. Here are bricks being unloaded from the kiln. They are either stacked out to the side or loaded into trucks to be sold. Here are new bricks being loaded into the kiln. They'll start with a layer of fired bricks to hold the bricks off the ground, and then they will stack the raw bricks into the kiln. And then this entire section here will get covered in a dirt layer to seal the bricks in and provide a uniform temperature profile for the firing of the bricks. It may be noted here, the bricks go in looking very gray. Obviously, a very high iron content in the bricks, which turns the bricks from a gray color to a red color, from the iron in the brick going from possibly a Fe2 state to an Fe3 state to an oxidized iron state, and gives that red color to the bricks. So the bricks are fired in sections, and they will seal off sections while they're being fired, and so they can load in new bricks. You don't want too much in-leakage of air because that cools too much of the brick, and would be pretty much a waste of coal going into the process. So, I mean, the kilns try and be very efficient with how they add coal to the kiln, but it's still a somewhat inefficient process. Again, you can see here sections that are being covered, being held off, being sealed away from the air, while other sections are being fired. So the brick starts out really from a pile of mud, really, and they've got these diesel motors connected to a mixing machine. The mixing machine will mix the clay properly until it comes to the right consistency. The brick making material is extruded from the bottom of this mixing machine, loaded onto carts, and then taken it out to the field where they will drop it into molds and create the brick pieces itself. Along with just the coal, because like I said, the coal just does not burn instantly by itself. Some amount of wood or some other combustible material is necessary to get some temperatures going inside until you can get a high enough temperature that you can get the bricks actually to fire. Here, bricks being dried in the sun. So as I told you, they've got two designs. We've got the traditional design and the zigzag design. In this kiln, they use a draft fan. It's basically a fan, it acts like a pump. So it'll actually move the air out of the kiln and drive it up the stack. And they use a diesel motor connected with pulleys and belts to be able to drive the fan. This one has two diesel motors and a cooling water tank. And I'll try and show you some more of that. So this is basically the radiator for the motor. As one motor gets too hot, they will shut one motor off and switch over to the other, so they can maintain 24-hour airflow through the device. The zigzag design, because you're pulling gases down away from the combustion process versus them being naturally drafted up, requires to put a fan in for this kind of design. As heat rises and cool air sinks, it's the same way in a brick kiln. Here is you have to have the motor to be able to get the gases to travel the wrong direction. But we believe that this is the more efficient design, but it does require some sort of motor or mechanical process to be able to get the gases to move. Again, another picture of the fan. As they dry, they're stacked up into these vertical rows. Here again are ports being fired. This kiln had around 48 ports that were being fired at once by these gentlemen. Here it is looking inside one of the ports. We didn't get a temperature measurement, but we estimated these were running at around 600 to 700 degrees C inside the kiln, based on the temperature and what we've seen before with coal combustion. Again, another view inside these coal ports. Again, brick is fired and loaded in. It's a 24-hour process, so you can see new bricks here being loaded on the back end. These gates here are used to control flow inside the kiln so that they can block off sections and maintain heat in the areas that they want to maintain the fire without letting a lot of the hot gases escape into areas where they're being loaded or where they don't want to be firing in. So this is one of the cone piles of one of the sites that we visited. Here, this is a higher grade grind and possibly higher grade coal than was being used in the provisional site, possibly also increasing the efficiency of the kiln through better combustion. And this facility, despite it already being fairly finely ground to begin with, goes through a second grinding process. They've got a diesel motor off to the side, and then the grinding machine, and then their fine ground coal in here. It was very fine, almost just like baby powder, just a very fine powder. Fine ground coal. And this is the material that's actually being, the final product being used to fire the bricks at this facility. Here are the fans that I was talking about. These are the actual fans that are used to move the gases. Some people may call these blowers. These are vanes that help capture the gas, just like a fan, just like the fans up here. Just an axial design versus a rotary design. As we observe, these things operated around 1100 RPM. And just to point out, I'd ask Dr. Salam as we rode at the plant every day, we would pass these piles of brick, and I'd see these people with grinders, grinding brick. And they were very careful to size the grind, and they had very beautiful piles of this fine ground brick. And as we understood, it's actually used in the asphalt road base or as aggregate. Because Bangladesh does not have, at least in this area, does not have a lot of rock or stone that they can use, and very expensive to import. Much easier to take, bricks, broken bricks that wouldn't be normally sold, and turn them into another product here. And so it made it, I thought it was a really good use of the material that was not able to be fired or be used as a whole brick. Dr. Salam has been great to us. He's allowed us to use our laboratory to perform our initial calibrations and our post-calibrations and to store our material here. We had originally planned to come back in January, almost a year ago, and Dr. Salam has had our equipment for some time now. And anyway, we're very grateful to Dr. Salam for allowing us to just keep our stuff here safe, so we were able to show up. So. And provide us with a chemistry laboratory that we can work on our equipment and really get this project started. So just to talk about some of the technical difficulties, this picture almost says it all right here. For typical stack sampling, we require some sort of port to be able to get our probe into the port. We've got a very long probe that's supposed to be able to reach the center of the smokestack, and what it normally requires is like a 6-inch hole on the side of the stack where the probe is inserted in and where we can draw the gases out onto a filter for sampling. And so our great host was able to construct some scaffolding for us, and but unfortunately we were unable to get a hole built, and really we were concerned for a couple different reasons. For putting a hole in the stack is that we hate to ruin the stability of the stack by putting a large hole in this kind of facility. But thank goodness they actually have a hole at the bottom of the stack. So I would assume after monsoon season there could be quite a bit of water in the bottom of the stack that had collected over the 6 months when it was very rainy, and they needed some way to